Fine. Let us continue where we this one. On previous class, if I'm correct. Okay, we talked about previous class about airfield ratio and SA engine. This was a slide we were talking, correct? And advanced all those things. Quickly, we'll go through functional block diagram, correct? So in electronic throttle, another thing is controlling the throttle, correct? You can control the throttle electronically, correct? Electronic throttle control. What it means is we can see that inlet air is coming, correct? Inlet air is coming from here. Correct. The throttle body in the preview, I will show you the map where it is. Yeah, you can see that this is a throttle. Correct. So throttle is vertically. Now it is in the idle condition. Correct. Idle condition. Even though air is entering from here, from atmosphere, so this air can go inside only through bypass valve. Correct. So this is completely closed when throttle is 0%. Correct. When I press the throttle 10%. What happens is already we have talked about it. Correct. So what will happen? This will become horizontal. Correct. This is throttle cross sectional view. That means all air can go without any restriction, go and fill the combustion chamber. This is what 0 to 10% throttle is made using when the driver is pressing throttle demand. Correct. So driver is pressing the throttle mechanically. There's a mechanical link. So which in turn, because the driver may be sitting in this one, correct, holding the steering wheel, and there is a throttle, correct? So this is throttle pedal and pivoted. There's a mechanical link, correct? There's a mechanical link between these two, correct? This is a mechanical link. So when he presses this, the throttle opens, fully open, fully closed, correct? So there's a, but how much throttle is opening is sensed by throttle position sensor. So here the port fuel, because conventional, most of the vehicle what you say without this one, it is manually controlled. Throttle is manually controlled. Driver demand. It is called driver demand. Driver demands the torque. So how? By pressing the throttle pedal, correct? Which in turn mechanical link. There are links and joints which physically connects, correct? Throttle, correct? So the throttle place opens and closes. Okay. So accordingly, the amount of air going inside the combustion chamber changes. Okay, so how much throttle is opened is measured by the TPS, throttle position sensor, which gives 0 to 90 degree, correct? 0 to 90 degree measures. It is a sensor, correct? It provides maybe 0 to 5 volts. Throttle position sensor, we have correct, will give 0 to 5 volts, depending on the throttle fully closed. Fully closed can give 0 volts. That means ECU know this because throttle position sensor is connected to ECU, correct? ECU. So ECU measures calculates the amount of air flow. Correct. So airflow using throttle equation. So, but in throttle equation, one of the parameters is theta. Correct. The air volume. Correct. Air volume consists of some equation in which one parameter is theta. The theta value is supplied by the sensor. How? It is 0 to 5 volts. It is calibrated. If the TPS gives 0 volts, the CPU knows that throttle is fully closed, 0 degree opening. Theta equal to 0. When if it is 2.5 volts, for example, it may know that 45 degree. Correct. 5 volts means it knows the 90 degree. It is linear. Correct. Theta versus voltage. Correct. Is 0 to 5 volts. 0 degree to 90 degree throttle opening. Correct. Throttle. And this is 0 volts to 5 volts. So it is a linear graph. This voltage is given to the ECU by this. Correct. So by measuring this voltage, because already you are calibrated. Please note that all these things you have to do calibration. So accordingly, ECU knows that if it is gets 1 volt, correct? If you know that means you know that the driver has pressed the throttle 20% throttle, correct? If it is 3 volts, it knows it is 60% because it is a linear curve. So this value, the voltage, correct? 0 volts, correct? 0 to 5 volts will be going, and the ECU will by measuring this voltage. Already there's a table, correct? So whether 0%, 10 by all this thing it calculates. So then this value, the theta, value will be substituted inside the throttle equation, correct? The theta value will be substituted in the throttle equation, correct? Throttle equation already you are written as a program. Throttle equation is already available, readily available, in which one of the parameter theta, other is the throat diameter, correct? Other things, other constant, all those things. This is only variable. This variable is controlled by driver by pressing the throttle pedal. So this butterfly valve opens fully close to fully open condition. So the theta, that's how it works, correct? So this is called mechanical, manual, the fuel injection, but manually controlled. But in some cases, if you want the vehicle to control autonomously, correct? If you wanted to control the vehicle autonomously, the throttle also should be electronically controllable, not mechanical force, correct? So that means what they do is, here the throttle plate is there, correct? You have the throttle plate, correct, which is, this is closed condition, this is connected to throttle pedal, correct? So mechanical. Instead of that, this will be attached to a motor. It will be attached to a motor, correct? So there is no mechanical linkage, correct? There is no mechanical linkage, but what we will have is, there is a small modification. There is a small modification is that your TPS sensor will be connected here. TPS sensor is connected here mechanically, but there's no link between the motor, the throttle pedal and the throttle valve. This is throttle valve. There's no mechanical linkage. Here there's a sensor, or a TPS sensor is there. This voltage, correct? So you can see that when the driver presses the pedal, correct? This is driver presses the pedal. He is giving a force through your leg. Then what you are doing is, there's a pivoter, there's a throttle position, it is nothing but a sensor, correct? This sensor generates, depending upon this one, 0 to 5 volts. This is the sensor, throttle position sensor, which generates 0 to 5 volts. And this voltage is given to the motor, correct? This voltage is given to a motor, correct? The motor will open or close. So that means the motor is controlled by 0 to 5 volts, which in turn is generated by 3PS sensor. And there's no mechanical link. So this is called electronic throttle control, correct? Electronic throttle control, correct? Otherwise, but in many units, the throttle is not connected to like this, correct? Because this one configuration, in one configuration, other one is like this. So when the throttle pedal is pressed, correct, force is applied, TPS sensor 0 to 5 volts, this voltage is given to the ECU, correct? To ECU, correct? Voltage is, this electronic control unit measures, and which in turn generates the control signal, gives to this one. So most of this one will be like this, correct? The driver is pressing throttle pedal, the TPS sensor generates 0 to 5 volts for 0 to 90% throttle, 10% throttle opening, correct? So opening, so that voltage which is given to the ECU measures this voltage, then accordingly it generates the control signal, throttle control signal, correct? Throttle angle control, you can say that throttle angle control signal is given to the motor. Here DC motor is there. You can see that here this throttle plate is connected to a DC motor. There's no mechanical linkage, correct? DC motor, or it can be a stepper motor also, correct? Many times they use DC servo motor or stepper motor. Stepper motor is cheaper, there's advantage, correct? So they can use some motor. So the motor gets command from the ECU, correct? When the TPS sensor is sensed and given as input to the ECU, which in turn the ECU finds what is the angle, throttle angle. Accordingly, the actual opening of valve, closing valve is done by a DC motor, correct? This is called as electronic throttle control, correct? That is called as electronic throttle control. So the throttle body, inside which there is a throttle valve, correct? The valve is controlled by this motor. See, the throttle valve is physically connected to the motor shaft. So motor in turn is controlled by ECU. So the amount of air, what it has to go will be decided by theta, correct? Theta degree, what the throttle is opening, that is controlled by DC motor, which in turn gets the command from the ECU. ECU gets the driver demand from the TPS sensor from this one. So this is called as electronic control. So by which we can make the vehicle electronically controlled. Throttle also controlled electronically. Correct? So air is sucked in and air goes into this one. Combustion happens inside combustion chamber. Correct? Which in turn produce a torque. So you can note down this functional block diagram. We can see that when electronic throttle control, driver is demanding throttle by pressing the throttle pedal. The TPS sensor provides a voltage 0 to 5 volts. Correct? Which so you can remove this slight modification. Only one thing you do like this. This is the more this one. So this line you can remove. The motor voltage is given by ECU. Correct? ECU takes the, so when driver presses ECU takes the TPS sensor value. You can see here. Correct? So this is the TPS. Correct? Which in turn generates the control. But here you can see that this figure also correct only. There's nothing wrong in it. They're using two ECU. One ECU for fuel injection. Correct? Fuel injection ECU. Other one is throttle control ECU. This is also correct only because when the driver presses throttle pedal, the TPS sensor, this is signal coming from TPS signal. Correct? 0 to 5 volts is given as an input, which is called driver demand, as an input to the electronic control ECU, which in turn as an interlude already your program. Correct? You can program and accordingly generate the control, motor control voltage. So it goes. Okay. So the other one is engine control. Otherwise, sometimes if it is a low cost single cylinder engine, all those things, same the electronic control unit, which is used for fuel injection itself, can be used as a ECU for generating control signal. Both are possible. Correct? So the motor control voltage control, that is throttle valve. Correct? This is nothing but throttle valve control motor signal. Can be generated by same ECU which injects the fuel, or you can have two separate ECUs. That means it is slightly expensive, but because there are two ECUs, both are possible. So this one accordingly, you can see that this is TPS. Correct? When driver demands, TPS signal gives actual how many degrees the throttle is open. Correct? So throttle. See, when you press, the driver demands. Correct? Control signal, which in turn is read by the electronic control throttle. Correct? So the appropriately the motor control voltage generated, given to the motor connected to the throttle body. Throttle body rotates because in throttle body only here the TPS sensor is put here. Correct? How many degrees TPS sensor is put here? How many degrees the motor has rotated? So the throttle valve open, whether 0 to 90 degree. This signal is given as a feedback to the controller. Correct? So you can see that this signal is given as a control signal. Correct? Driver demands the ECU. Correct? The ECU sets the control voltage depending on this one, which in turn activates the DC motor. So the throttle body rotates. Correct? Throttle valve. Correct? Not body. Throttle valve rotates 0 to 90 degree depending upon the command signal. Correct? It may be 0 to 5 volts or 0 to 12 volts. Depending on what motor you are using. The DC motor, what is connected to throttle valve, maybe 0 to 5, 0 to 12 volt, whatever may be. Accordingly, that's what voltage generated. That depends upon the driver demand. Correct? Driver also has a one sensor, correct, which measures how much the throttle pedal is pressed. Correct? Throttle pedal is pressed. Correct? So you can have a linear sensor also. Correct? Throttle pedal you are pressing. This is throttle pedal. Correct? So you using your leg, the driver is pressing. Correct? He is pressing. The force is applied. So this displacement. Correct? This is a linear displacement. Correct? It may move 0 to say for example 28 centimeter or 0 to 30 mm. or 0 to 50 mm, the throttle. So this is sensed. That is what is given as a the displacement, how much depending on force you want, correct? So this is sent by driver pedal command. Again, this is a sensor, correct, which measure how much the throttle pedal is pressed. So whether 0 means throttle is idle condition, correct, 30 mm maximum, 3 centimeter or 5 centimeter, depending upon design, correct. So you press, this movement is measured by a sensor that is called driver command. Based on that, the throttle controller generates a control voltage for motor 0 to 12 volts, correct. When the 0 volts means throttle is completely closed, 12 volt means throttle is fully open. So the control voltage is generated. So that depends upon what is here, correct. So now I can say that this sensor is 0 to 30 mm is translated to 0 to 5 volts, correct. When driver is not pressing this one, is 0 volts. When you want to accelerate, you are going to press your throttle pedal. So for easiness, for our convenience, what I'll do is I'll make this also 0 to 50 mm is the movement of the throttle pedal, right, by driver. Okay, so now this generates 0 to 5 volts. Now that is given as input signal, correct. Please note that the mechanical movement is converted to the electronic signal by a sensor. You need a sensor which measures the movement of the pedal, correct. So 50 mm the maximum, that is nothing but 10%. 0 means 0 to 10% throttle, correct. That's what as a mechanical driver is doing. But please note that in electronic throttle, the mechanical linkage is not there. Instead of that, there's a sensor which measures how much the driver is pressing. So that is given as input command, correct, driver pedal command. Okay, that is nothing but torque. They call it driver torque demand, correct. Driver torque demand, correct. Why it is called torque demand? Because you are asking engine to produce torque, so much torque, then only vehicle can accelerate, go faster. Correct? That's what driver is trying to do. By pressing the actual pedal, it is called driver command, which is a driver torque demand. That's what a correct technical term. When you press the throttle from 0 to 50 mm, I say my engine can produce a 0 to 10 single cylinder 0 to 10 Newton meter force. Correct? I say that by pressing my throttle pedal 0 to 5 volts, which is nothing but 0 to 50 mm. Correct? Throttle movement. Correct? Throttle pedal movement, which is converted to sensor given to ECU. What I'm saying, the engine should produce 0 to 10 Newton meter. When you produce 10 Newton meter, my vehicle may be going at 80 kilometers per 100 kilometers. Correct? When it produces zero torque, it not possible. At least idling torque, I can say that, say 0.5 Newton meter. Correct? Or 0.3 Newton meter idle condition. Single cylinder engine, correct? To overcome friction, engine will be running idle condition. So it starts from 0.3. When the engine started, it produces at least minimum 0.5 Newton meter. That then only can overcome the friction in the shaft, inside the piston cylinder, all those things, and the engine can rotate at idle speed. Correct? Idle speed, it can rotate. For that, some amount of torque engine has to develop. That will be done. So beyond that, if I press the throttle pedal, that's what is happening. So you are demanding. So engine has to produce this. So for that, it has to suck more air, correct? If you want to produce more torque, correct, engine has to produce. In fact, engine is called as an air engine. Literally speaking, it is called air engine, air combustion. Basically, we have always said that we are burning fuel. I told you many times, in engine, we are burning oxygen available in the air, correct? To burn the burning is nothing but called combustion. Burning of oxygen, how it oxygen will burn? When it combines with other elements like carbon, hydrogen, which is called oxidation, correct? That is called oxidation. Oxidation process is called as, theoretically it is oxidation process. That is whether oxygen molecule is combining with carbon or oxygen molecule is combining with hydrogen in petrol. It produces CO2 and H2O, correct? So combining oxygen with carbon or hydrogen in the petrol is called as oxidation process, which we call as combustion, correct? We colloquially we call it burning the fuel, correct? We are not burning fuel, we are burning the oxygen, correct? That's what we are to do, fuel injection. Please note that when piston goes down, you are sucking the air, correct? Doing the suction stroke, when piston goes down, the air is sucked in, correct? When piston goes down, correct, during suction stroke from the TDC to BDC, correct? The air is coming in, correct, to inlet port. There's a valve, something here. The inlet port, air is coming here, correct? So it comes and fills the vacuum created inside the combustion chamber, correct? This is vacuum created end of the suction stroke. Air will be filled. That time we are injecting fuel. So we are injecting fuel based on how much air is sucked in, correct? It is not reverse, correct? We are not sending air for this much of fuel, correct? So that's what the main thing. So that means we are trying to inject fuel, correct? We want to inject fuel depending upon how much air went through the throttle body to combustion chamber. That's what this block diagram shows, correct? When piston goes down, there's a vacuum created. Air from the atmosphere is flowing through throttle body, through throttle valve opening, and goes to inlet manifold where the fuel is injected, correct? Because in port fuel PFI engine, where we are injecting in the throttle body, end of the throttle body, where inlet port, correct? Inlet port, but still it is part of the inlet manifold only, correct? So then the air and the fuel mixes, and air fuel mixture is created, correct? Air fuel mixture is created. You can see that I am circling here. The air and fuel mixture enters in the combustion chamber. Then of course compression happens, gives spark, and then combustion happens, and power stroke. Further combustion continues till the power third stroke, and finally when it comes down, piston comes again, start going, which is called as exhaust stroke. The exhaust valve opens, the burn fuel just goes out, correct? What is the outcome? See, this functional diagram very, very important, correct? So air is going in, correct? It is electronically controlled by throttle. That's why electronic throttle, because the throttle valve is driven. The throttle valve is driven by a motor. Is driven by a motor. Motor in turn is controlled by electronic controller, which in turn controls depending on driver demand, correct? How much throttle opening is sensed by TPS sensor, correct? So TPS sensor is a feedback element. TPS sensor is a feedback element. What it does, when you press the throttle pedal, correct, by the driver, correct? So the throttle is there's a sensor which measure how many mm or force by applying force it goes. I told you 0 to 50 mm, correct? So throttle is moving up and down 5 centimeter. So that is sense, that is given as a driver command, which is given as 0 to 5 volts. Based on this driver demand, the ECU develops a voltage 0 to 12 volts. For example, this motor is a 12 volt DC motor, correct? So this 0 to 5 volt converted to 0 to 12 volts, which in turn will open the throttle body, correct? Because the voltage given is 0 to 12 volts, the electronic controller. What happens when I give 0 volts? Throttle is 0 degree, correct? Theta is 0 degree, correct? When motor gets 12 volt, this one, what it gives? Theta will be 90 degree, fully open. This is 10% throttle. This is 0% throttle. So you can see that the throttle also 0 to 5 volts. It is nothing but 0 to 10% throttle. Correct? Command signal is very simple. Correct? This functional diagram shows how the command structure happens. Correct? Closed loop control of electronic throttle. Correct? So basically, driver presses the throttle pedal, correct, which travels 0 to 50 mm because a linear movement, throttle going in and out. This linear movement 0 to 50 mm is measured by a sensor, correct? A sensor put on the throttle pedal, this one, which in turn converts 0 to 50 mm is converted 0 to 5 volts because it's an electronic throttle. This signal goes as input, command signal, correct? The command signal goes in. Okay. Now, based on the input, this one, the electronic throttle generates 0 to 12 volts because my throttle is controlled by a DC motor which works 0 to 12 volts. Correct? If I give, generally it will be a servo motor. It will be a DC servo motor. It will be a DC servo motor. Correct? I will tell you why it should be DC, not a pure DC motor. It will be a DC servo motor. DC servo motor only you can control your angle. Correct? Pure DC motor means only can control speed. Correct? DC motor, speed can control. Correct? But if you want to control angle, you have to give a feedback, which is called servo motor. So don't worry about it. It is a DC servo motor. For DC servo motor, you 0 to 12 volts, it will move 0 to 90 degree because this is physically connected, correct? Physically connected. You can see that there's a shaft through throttle body, correct? It is connected to throttle body open 0 to 90 degree. So when it opens, accordingly, the amount of air going inside the cylinder through throttle, the intake manifold into the combustion, into the cylinder varies. That's what we do. We want to controlling throttle. Now when the driver presses, for example, if the driver presses, say 5 mm, correct? We know that if it is presses, what should be voltage coming from this? We know that 0 to 50 mm equals 0 to 5 volts, correct? So that means 0 to 5000 volts. When throttle is pressed to 50 mm, that means 10% throttle. How much voltage generated? 5 volts, which is nothing but 5000 millivolts. Correct? 5000 millivolts divided by 50 mm. Correct? Is called sensitivity. Correct? Is called sensitivity. So how much is that? It will generate 100 millivolts. Correct? It will just say the sensor, throttle pedal sensor will generate 100 millivolts if 1 mm is the throttle pedal moved by 1 mm. Correct? So that 1 mm is converted into the 100 millivolts, which in turn is given as input to throttle, this one. Now, this voltage 0 to here, what is the voltage? This is electronic throttle controller. It has to 0 to 12 volts when it gets. So that is 12,000. Correct? 12 millivolts means 12,000 millivolts. Correct? Divided by 5,000 millivolts. Correct? We know that is nothing but 2.4. Correct? It is something around 2.4. Correct? You get around 2.5. I don't know. Okay, 2.4 only. Correct? This is the sensitivity of the controller. Correct? What it does, if I press a throttle pedal by 1 mm, correct? If I press by 1 mm, correct? How much this is going to give? Is going to give something around, yeah, no, 24. Okay, so 24 millivolts. Correct? If input is 1 millivolt, this will give 24 millivolts. But if I press a throttle pedal by how much we said, 50 mm, correct? Into 50, correct? 24 into 50 is the voltage generated by the electronic controller, the throttle controller to the motor. Correct? It's going to be 1.2 volts. Correct? 1.2 volts will be supplied when driver presses the throttle pedal by 50 mm. Correct? What it will do is this will generate the throttle sensor will generate this much voltage. Correct? 50 millivolts. Then when 50 millivolts supplied inside the throttle controller, the throttle controller will generate a voltage of 1.2 volts, correct, which will be given to motor. Okay, if 1.2 volts is given, correct, what will happen? The throttle should, correct, when 12 volts is given, correct, when 12 volts is given, the throttle will open 90 degree. When 0 volts means 0 degree, correct. Again you can map, correct. So 90 divided by 12 volts will be the this an angle when throttle moves by 1 volt, correct. So or you can convert to millivolts also, same thing. When you do that, 90 divided by 12, okay, I think 90 6 7 something around 7.5 volts. If you give 1 volt, correct. So 7 point some volt degrees, correct. 744 degrees will move, correct. If I press my throttle by 5 mm, what will happen? My throttle valve will open by 7.4 degree, correct. This 7.4 degree This is nothing but theta. That will be given to the throttle controller, correct? Throttle control equation. So ECU can find out how much air is venting, correct? How much air is venting. So 7.4 degrees opens, correct? So that is given as feedback. You can see here the TPS sensor, which is attached to the throttle body, provides the feedback signal. So the electronic controller knows whether it is giving right amount. You can see that this is input, demand, this is the feedback, correct? So this is the closed loop throttle control, closed loop throttle control, correct? So this is the demand signal or set point. We call it as a set point. When is given, then the controller generates voltage and is given to DC servo motor. Servo motor itself open the throttle. On the throttle body, actual TPS sensor is attached, which measures the how many degrees the theta is open, correct? Whether 0 to 90 degree it measures, and that is given as a you can see here, that is given as another input, correct? So in closed loop. So now it controls. So the electronic controller sees that the difference between the set point and the TPS sensor should be 0, correct? That means the whatever the driver demands, that is maintained by the electronic controller. This is how the electronic throttle controller works. Okay, then this same signal, please see that the same signal is in this figure. There are two controllers there. One is for electronic ETC, electronic throttle controller. Other one is ECU for fuel control, correct? So they are talking with each other. They are exchanging data. So now the electronic throttle controller calculates the amount of air venting based on TPS and all those things, provides the information to mass of the MA, correct? MA is given to the ECU, the fuel injection controller, which in turn calculate MF, fuel quantity, correct? Once fuel quantity is calculated, how? We know that AFR equal to MA divided by MF, or MA dash by MF dash. Both are same, correct? Rate of fuel airflow, rate of fuel flow, or mass of the, sorry, mass flow of air, mass flow of fuel, or you can say mass of the air divided by mass of the fuel. So air fuel you want to maintain 15:1, correct? That means it is 15. AFR equal to 15, correct? And amount of the air venting or mass of the air is maintained is calculated by the throttle controller based on driver demand, all those things. That is substituted in the top, say for example 10 grams, correct? Now the ECU generate mass of the fuel. So mass of the fuel is nothing but 10 divided by 15. So many grams or milligrams of fuel should be injected. So that is done by ECU, which in turn opens the pulse width, correct? The electronic pulse width duration, correct? We know that it is a PWM pulse, correct? This duration is varied, correct? 1.5 millisecond to, say for example 4, whatever maybe, depending upon the already talk. We don't have time to talk about this. Already your injector is calibrated accordingly. Once the fuel mass is known, the ECU knows the lookup table. Based on that, it will open the injector for duration, PWM pulse width, correct? So this is how electronic throttle control. This is the next step closer to autonomous vehicle. In autonomous vehicle, the driver is going to press the throttle pedal, but it is not mechanically connected. That's what I'm saying. The throttle valve is controlled by a DC motor using one more ECU, correct? There's no physical mechanical linkage. But in autonomous vehicle, this driver command is coming from the master controller, correct? So driver presses accelerator and decelerate depending upon whether you have to go fast or slow, or there's obstacle in front of you, all those things. So driver is driving. But in the autonomous vehicle, there's a master controller which uses lidar, radar, lane, camera to find lane, all those things. It generates the control signal. The driver, instead of this one, electronic signal. Please note that the driver pedal also produce electronic signal only. Now the ECU can directly, this master controller can directly produce the control signal instead of having driver pedal at all. There's no need for throttle pedal, correct? It senses using the radar, lidar, distance, what speed it has to go. It will set this set point. What speed vehicle has to go, correct? That is called set point, which is driver demand. That is done by using sensors. So this is the next step from manual control, electronic control. That's why the ETC I'm talking this. Okay. Next one is if you wanted to do modeling simulation, all those things, you can model the vehicle, the engine itself. Correct. Air fuel ratio control structure. Correct. You can do air fuel ratio control structure like this. Okay. You can do this like this. What is this? You can see that this is the atmosphere, this air from atmosphere, correct? When this is the throttle, correct? Throttle, when throttle can open this angle, throttle angle alpha, correct? This varies from 0 to 90 degree. But now 0 degree means it is completely closed, something like this. Okay. Correct? This is 0 degree. Theta equal to, alpha equal to 0 degree. Throttle angle generally measured. So ideal condition it will open a little bit. That's what is shown here. Correct? Correct. It is not fully closed. There's a small gap. Correct. This is called ideal condition. Sometimes you can give a bleeder valve. Correct. Additional valve. Always in same throttle you can make such a design of throttle body such that it is not fully closed. Small gap is there. Small gap is there, so air can go in when throttle is not pressed in ideal condition. The ideal condition, driver is not pressing the throttle, correct? So through which air will enter into cylinder. Okay, so this is the ideal condition is shown here. Okay, now depending upon the throttle opening, correct, and pressure, atmospheric pressure, P ambient is ambient pressure, atmospheric pressure, and the temperature of the air. This is nothing but with air temperature, atmospheric air pressure and temp is called pressure AMB, atmospheric pressure and atmospheric pressure. Please note that both are not constant. They are not constant. Correct? If you are at sea level, it is 1 bar. As the altitude goes up, it becomes 0.9, 0.8, like that it comes down. Correct? As you go higher and higher. From the sea level has to go to mountain region, this one. Similarly, the temperature at sea, the temperature depend upon altitude, correct? If you are at the sea level, early morning, for example, Chennai told you, maybe 22 degree, correct? Morning, 6 a.m., correct? At the same 6 a.m. in Ooty, which is high altitude, correct? The temperature may be 5 degree centigrade. Please know the same 6 a.m. in both the places, Chennai and Ooty, correct? This is Chennai. The temperatures are different, correct? Then pressure also different. T also varies because you can't control. Naturally happens. So they are variables. So that's what you need to measure the. If these two things are varying, correct? If these two things are varying, these two things are varying, we can know that the amount of the mass of the air, correct? Mass of this is m-at, mass of air entering. You can see that from this one. This is nothing but the whole thing is nothing but your manifold. It is manifold, correct? It is nothing but a pipe, correct? It can be twisted, all those things. It has, for understanding purpose, here it's shown as a box like a pipe. They basically pipe all those things. Wherever throttle there, it may slight bulging will be there, correct? So that's okay. Throttle body, correct? And depending upon alpha, correct, throttle angle and P ambient and T ambient, correct? This mass of the airflow, this is rate of mass flow, correct? Mass of the air or mass of the airflow rate, correct? Inside the combustion chamber, this is your combustion chamber, correct? So the piston is going down, suction stroke, correct? Vacuum is created. Vacuum is created in the suction stroke because piston is moving on. This is the TDC. This is TDC. It may go up to, say, for example, this is BDC. Correct? As the piston goes, vacuum is created. So the air from the outside is rushing if throttle is opening. Correct? In ideal condition, throttle is open a little bit, so air is moving. Okay. So because atmospheric air, atmospheric pressure, atmospheric temperature, and throttle angle, depending on that, there's a mass flow rate because the mass flow rate, correct? Air mass flow rate is decided by the restriction, all these things. So once it enters to the throttle body, which is nothing a tube, correct? Inside which this is atmospheric pressure outside, correct? Here the inside the atmosphere near the this is the inlet port. This inlet port, correct? This is the inlet valve. Inlet valve, correct? Inlet valve will be open during suction stroke, correct? So that's why the air is going in. Correct. As it goes in inside the throttle, is temperature, all this thing varies. Again, inside throttle body it varies. Correct. So this is called pressure at manifold, pressure at temperature at manifold, inside the manifold. This is pressure of the air inside the manifold. This is atmosphere outside. Correct. Inside this one, because restriction, all these things are, there's a pipe, there are restriction. Correct. Pressure changes. Correct. And the temperature changes. Correct. When restricted this one, air may be compressed, velocity increases. Correct. Due to that, there will be a pressure drop. There's a temperature drop. Correct. So the mass of the air entering into the this is the mass of the air. Mass of the air rate. Correct. At manifold. Correct. That also varies. So then finally the air enters in the combustion chamber. So you can see that every stage this pressure, temperature, correct, mass, correct, is varying. Once it enters, again there is a restriction, again there is a pipe, there is a valve, correct, valve, there is a opening, correct, this inlet valve open, there is an opening through which only again there is a restriction, correct. So because of the mass flow rate of air entering into combustion chamber, correct, is restricted by many things. One is throttle is restricting, then the throttle body, which is a pipe, is restricting, then inlet valve, here there's a restriction, or there's a small gap through which only it is opening. All those things going to help what you call volumetric efficiency. Correct. So volumetric efficiency, we don't have time to discuss, although I'm just giving you an idea. Correct. Finally, because all the restriction, finally, what is this? So you can see that finally the amount of the air mass inside the combustion chamber, correct, air mass inside the combustion chamber, the end of the suction stroke is totally different, correct. M dash AP inside the combustion chamber is the final air. At the end of the suction stroke, when the end of suction, what will happen, this throttle valve, this will close, correct, inlet valve will close, so no further air can come in, correct. So even though this atmospheric pressure is this, atmospheric temperature is this, it is not going to be same. So due to this, there is a one mass flow rate entering into the past this throttle valve. This is the air mass flow rate, which in turn will again finally get this up, because it creates again the throttle body also is a chamber, correct. It is accumulates some amount of air, correct. So then because here the restriction is small, correct. So this opening compared to that, the volume of the compared this volume, correct, where the air is entering to restriction throttle ideal condition, this volume is much small compared to the manifold volume, correct. So the air from atmosphere, it enters to restrictions, so the mass flow rate is controlled, air mass flow is controlled depending upon the ambient pressure, ambient temperature, and throttle valve opening alpha, correct. This comes, which is accumulated. Again there's a different pressure compared to atmospheric. P amp is not same as P manifold, correct. Similarly, T amp is not same as T manifold, inside the manifold, because the pressure different, flow rate, all these things changes both these things. Then again the mass of throttle, correct. So this is nothing but mass of the air crossing the throttle from the atmosphere, correct. There's a restriction. Mass flow rate of air flowing through the throttle valve is MAT. MAT is not same as MAN. M, correct. The inside this, which in turn will again restrict going inside through this inlet port. This is inlet port, and inlet valve, there's a restriction. So finally air entered. So that means finally we can say that this is totally different, correct. Is not same as mass of the mass airflow inside the throttle body, correct. So this is not same as mass of AT. All are different because there are restrictions, temperature changes, pressure changes, all those things. Finally, what is inside the cylinder? Correct. What is inside the cylinder is this much air. Correct. This is the amount of air which is finally entered into the cylinder and end of the suction stroke. When comes to this, then for that you have to inject the fuel. Correct. The air fuel ratio is nothing but mass airflow inside the cylinder, correct, divided by mass of the fuel inside the cylinder, correct. So this is what the final airfield ratio, correct. But I said that if I wanted to control the engine with 15:1 airfield ratio, correct, what I am going to do, I need to measure what is the amount of the air entered inside the cylinder, correct. This one, this mass flow air inside the cylinder, correct, that we have to find out. But problem is you are measuring, for example, if we are attaching a TPS sensor here, and this throttle is controlled by a motor or by driver, correct. The throttle valve by pressing, electronic throttle means motor will open and close, the manual driver will press, mechanical linkage. So because of the throttle angle theta, this alpha varies from 0 to 90 degree, correct. When varies, so this varies, correct. Then this varies, further restriction also depending on all these things. Please know that these are all variable, correct. When engine is not running, correct, the everything will be at one temperature. Of course, this is a metal. This is engine is made of metal, correct. All throttle manifold, all those things. This temperature, engine body temperature, engine body or cylinder, all those things, body temperature will be much lesser than the atmosphere, T atmosphere or ambient, correct. Because metal will get cold. If you touch the metal body early morning, go and touch your engine, car, all this, it will be very cold because metal heat it quickly releases, become colder than this one, correct. So now as the engine start running, you will see that because this manifold is connected to engine, here the temperature will start going up from room temperature as the engine is going up to 200 to 300 degree temperature. The outside, here, if you cannot touch all these parts, will be around 200 degrees. Inside the combustion chamber, it can be 400 degrees. So because of the heat will be, this part also get heated up, correct. So that means air temperature may be 30 degree, correct, or morning, correct. When engine was starting, this will be same, correct. T amp and will be T manifold and will be same, but inside this cylinder it will be less because this body is a bigger body, this one. But as engine, this one, T manifold may go higher, correct. So this may be 30 degree, this may be 50 degree, 60 degree, because this is mechanically connected. Heat transfer will happen from here, all those things. So these things are varying, correct. So based on this, you can write the throttle body equation, correct. So now this mass entering, fuel injected, when you give a spark, combustion happens. Once combustion happens, at the end of the suction stroke, the exhaust valve opens. This is the exhaust valve, correct. Valve opens, the hot combustion gas just goes out, correct. So here you are measuring the lambda, air fuel ratio, correct. Air fuel ratio, AFR. How you are measuring? Using EEGO sensor, exhaust oxygen gas sensor, which measures the lambda, air fuel ratio, whether 15:1, whatever is happening, correct. Then you have three-way catalytic converter, TWC. Finally, after TWC, correct, again the lambda should be different. You can put one more thing, there will be variation. When we talk about lambda sensor, I will talk, we will find whether I can talk about a little more. So this is the model, correct. So this model can be written equation, correct. So basically it's called mean value engine model. I just complete this slide, correct, in which the intake air dynamic model, which is not about P dash manifold, correct. From the manifold loading inside the engine, it is going, correct. If you see here, from here, the air coming from atmosphere through the throttle body control comes and saved here, correct, is stored here. Where it is stored? Here. During it, you know that during suction stroke, correct? If we see the P, just 1 minute, I know the time is up. Anyhow, we know that this goes like this. It goes like this. Maybe little bit less, correct? So sorry, this will be like this. Small variation. I will tell you why what it is. I'll draw neatly so that okay. So this is the suction stroke, correct? 180 degree. This is 0 degree because four-stroke engine. This one. This is the compression stroke. 180 degree, correct? Here combustion happens. Combustion starts. Correct? We are giving a spark. Spark is given. Correct? This is the TDC, the top sensor. It goes up, correct? Then this is your power stroke. 180 degree. This is again 180 degree. It may go up. This is the exhaust stroke. Correct? During this time, exhaust valve opens and the hot combustion, this one is thrown out. Correct? So this valve opens open. So here you can see that the pressure will be lesser than this is 0 bar. This we are talking about pressure inside the combustion P inside the combustion chamber. Correct? Combustion chamber. During suction stroke, the combustion chamber pressure will be low. This is 0 bar. Sorry, this is 1 bar below that. Correct? So then only suction will happen. When the piston goes down, there's a vacuum is created. You can see that the pressure is shown lesser than 1 bar. So that's why air is going in. Then end of the compressor, this valve closes. This valve closes, compression happening. Just when piston comes somewhere here, this is TDC. Just 30 degree before or 30 this one which is called as this is TDC. Spark timing, correct? Spark time 30 degree, 50 degree by engine speed you have to vary. You will give you a spark, correct? So combustion starts, correct? Combustion starts. Combustion will continue up to this. This duration is combustion. Whole duration is combustion is happening. Starting from here up to this maybe or maybe end of this one. So more than something around 200 degree crank rotation, combustion happening. So peak pressure happens, the piston is coming down. That's how it works out. So now I will stop here. Here next class we'll show some equation how all these things are working. Correct? How you can develop model air-fuel ratio. You can do the simulation. Correct? If you want to do engine simulation, you need this is engine model. Correct? This is your exhaust gas equivalence ratio. Correct? Air-fuel equivalence ratio. This is the final equation. Correct? All these things I will just quickly say next this one. And in fact, you can, if you want to do modeling and simulation, this engine combustion finally all these things air-fuel ratio can be modeled as simplified first order equation, transfer function. Somebody was talking, correct? Previous class talking transfer function. Right? This is for air-fuel ratio transfer function. It is a first order signal with some delay. We will explain all this in next class. I will stop here. Okay, tomorrow we'll discuss. Then we can talk about engine control. Correct? Diesel engine control. We'll kind of close the engine. Then we will talk about just 2 classes. One is ABS, other one is the electronic control of steering. Correct? Steering control and brake control. ABS will talk. Tomorrow I will talk about this. Subsequent classes I will close with this. Okay. Then we can go to autonomous vehicle sensors, path planning, vision, all those things we'll see. Thank you. Any questions? Okay. No questions means no problem.
Sir,
yeah. Yes, please.
Sir, when will you have midterm exams?
Now, just a minute. How many classes over? I just wanted to know. I will find out. Generally, after 24, 25 classes, midterm. Totally 44. Around 22, 23 classes over means we will have the midterm exam. Okay. So I think now 14 classes or 12 classes over. Correct? Another 10 classes after that you will have midterm exam.
Okay, sir.
Thank you.
And sir, please share the slides and
yeah, that's what I told you. Slides are just I told you. Each file is very big. Correct. I'm trying to compress. I tried many software, they're very huge.